Good afternoon, everybody. We'll just wait a few more seconds before we roll forward. Welcome to some new faces and one or two here that I recognise from recent times too. So nice of you to all take the time. So, good afternoon, everybody. Good afternoon, everybody, and welcome to our latest webinar, dealing with the realities of sustainability in commercial lighting. Thank you for taking the time to be with us today. We hope you find the following webinar both useful and informative. Just a little housekeeping before we get started. If you have any questions during the presentation, please feel free to type them into the question box in your control panel. We'll bring them up at the end of the presentation, but please feel free to write them at any time. You'll hear from three of us today. My name is John Dale. I joined the lighting industry in '82, operating in a senior capacity for some total over many years, before leaving to establish Fire Lighting in 2003. So that's a happy 20th birthday next March for us then. Len Fincham, who's our sales manager, he's been in lighting for 21 years in senior technical and commercial roles, and at Fire Lighting for 16 of them. And Stuart Dancy, our technical director, who is a product and lighting designer by trade, with 20 years in lighting, 17 of them with Fire. Our direction of travel today will take us through several areas, including how sustainable lighting is a must for every business, and the urgency of the need that sustainability looks like in lighting, how positive actions can be implemented, and both the commercial and environmental reasons for this best practice and factors to address for success. We will also show a real-world case study of an award-winning project called The Old Gramophone Works, in which we undertook the lighting design and provided variant and bespoke versions of our super efficient momentum luminaire. Lastly, we will also look at how the circular economy and its impact on lighting selection, manufacturing, design choices in future. So, introduction finished. May I pass you over to Len, who will cover the first of these topics. Len.
Thanks, John. Over the next few slides, I'll try and deal with two distinct areas. The first area is identifying the need for sustainable lighting. The second area will deal with the application of the latest lighting technology in a commercial environment. So let's firstly deal with need. According to the Energy Saving Trust, lighting accounts for between 15 to 20% of the energy consumed in the UK. That's a scarily large figure in my mind. The Federation of Small Business also recently identified that 30% of businesses believe that energy costs are directly impacting their ability to compete in their marketplace. Another interesting statistic is this time provided by the Carbon Trust, who found that 30 to 50% of all energy consumed by any modern building across all industries is used for lighting. All of the above suggests that the need to eke out every advantage that modern technology and design can bring to reduce energy usage and carbon impact has never been more pressing. Older lighting installations are, by their very nature, prone to higher maintenance costs and downtime. And there are situations where broken lamps or illuminance interference could be a massive detriment to the output of a business and the operational status of its workforce. For lighting companies like us, we think it should go further, however, as it's not only solely a case of switching to solutions that consume less energy. We're endeavouring to balance the efficiency of buildings with a qualitative user experience, and in lighting terms, the management of glare and the lit environment. As we will see, the two are not always mutually compatible. Delving a little deeper into the present state of existing commercial lighting installations in the UK, a recent study by the lighting think tank Lighting Europe found that a 10 to 15-year-old lighting system can consume 5 times as much energy as a new system. The same study also shows that 95% of the environmental impact caused by lighting comes from through life energy consumption, which can be reduced by up to 80% with modern lighting luminaires and control systems. The movement towards a circular economy and a greater understanding of whole life costs, which we will look at further in this webinar, cannot happen soon enough. It should be no surprise to any of us here today that the UK is in a period of energy crisis, with a number of major issues causing prices to skyrocket. These include increasing demand, limited storage ability, a shortage of storage space for energy, and the obvious conflict in Ukraine. All these issues mean energy prices have increased at a frightening level in the last 18 months, and big bills are a concern for all businesses across the UK. Even those companies who are large enough or fortunate enough to have bought forward their energy are now beginning to see massive increases in their costs. According to a recent CBI report, energy prices could be set to grow by a further 18 to 24% in the next 5 years. Another major change in the lighting market happened in the spring of this year. The EU Commission revised the handling of mercury-containing lamps. Mercury is obviously considered a hazardous substance, and its use in electrical or electronic equipment is being prohibited. By the end of 2023, the production of T5 and T8 fluorescent lamps will be outlawed, meaning that the lamps for millions of luminaires across the UK, mostly in commercial premises, will become no longer manufactured, and the light fittings will soon become obsolete in their current form. For all the reasons mentioned in the previous slides, lighting offers a key opportunity for businesses to save money. But also, a further need to change is the desire of customers and staff to make greater strides towards sustainability and a greater overall efficiency. The growing focus on climate change has led to stricter government regulations and legislation, and all these responsible companies taking a closer look at the impact their actions are having on the environment. However, many organisations claim they are committed to operating in a sustainable manner for the betterment of the communities in which they operate, or use such statements as, "We use sustainably sourced materials." However, with the broadening reach of social media and the scrutiny that they can also be easily levelled by any number of ecologically minded watchdog groups, it is increasingly critical that such promises amount to more than just words on paper. Design teams need to be incentivised not just to specify low carbon materials, but to identify and design holistically with them an overall low carbon solution. The UK government has enshrined in law new targets to slash emissions by 78% by 2035 and to achieve net zero by 2050. Demand drivers, such as the above, and the UK government imposing requirements to demonstrate the embodied carbon of their buildings, are already encouraging the building industry to move to the next level. Important though it is, this issue is no longer just about the efficiency of products. We need to go further and deeper than that, examining the efficiency of our supply chain and the production techniques and sustainability of all materials and components to establish a whole life cost of ownership. One of the most recent high profile environmental events is happening as we speak at COP27 in Europe, which is likely to demand greater and deeper moves towards a more sustainable future. Out of last year's meeting held in Glasgow, obviously COP26, the UK's nationally determined contribution, or NDCs, was already one of the most ambitious targets for 2030 for reducing emissions in the world. However, the Glasgow Climate Pact, which came out of the COP26, requested that all countries, including the UK, revisit and strengthen the targets of their NDCs. In short, companies must hold themselves accountable before someone else does, whether that be their own staff, customers, or even governmental oversight. After all that somewhat negative discussion, there is good news. The rapid advancement of LED light sources in modern lighting products are so much more efficient than they used to be. It's now possible to achieve over 200 lumens per watt at source, and if correctly used with modern optical materials, you can still deliver impressive energy and in turn carbon savings. Even early adopters of LED lighting, some over 10 years ago, are now looking to make the change to the latest versions, such are the energy savings available. Another huge benefit of LED lighting is that they give you ultimate control. With wireless technology and the Internet of Things, you can program your lighting to vary to suit different purposes, roles that the space plays during different periods of the working week. It's always great to know that an automated system never forgets to turn the lights off like a lot of us do. Being able to control luminaires remotely via the latest management software allows monitoring and control of the lighting from anywhere at any time. It can view, compare and control multiple areas in single or multiple sites at a press of a button. This remote visibility also allows investigation into failed lights or other maintenance issues to take place quickly and effectively. It also allows scheduled lighting maintenance in advance to reduce downtime or to act quickly in the case of an outage. This helps cut maintenance costs hugely. No longer are engineers attending breakdowns with little or no information. They can attend with the correct components to repair or replace a faulty unit, as they know exactly what fitting has failed and where it is located. The use of daylight where available to complement lighting design, when integrated with an energy efficient lighting design and controls, daylighting can make a sizable dent in electric consumption. It seems strange that maximizing sunlight as a free source of illumination isn't always at the forefront of all designs. As mentioned in an earlier slide, good application of the latest technology should not simply be a case of switching to solutions that consume less energy. We should all be endeavouring to balance the greater efficiency with that quality user experience we spoke about. There is a huge range of regulations and best practice guidance in place for designers to follow. These include the Building Regulations, Part L, Energy Performance Certificate, EPC, the Energy Technology List, ETL. This next one's a bit of a minefield, folks. So the Building Research Establishment's Environmental Assessment Method, BREEAM, I'm glad I got that one right, and Chartered Institute of the Building Services Engineers, SIBSE, and last but not least, the Society of Light and Lighting. All of the above, whether guidance or regulations, should be read and understood, but also observed in relation to the space being illuminated. Hopefully we're seeing an end to the desire to produce a totally uniform 450 to 500 lux across the whole floor plate in offices, to a more nuanced and thoughtful illumination of the space designed around the varying needs of the user. This approach also has the added benefit of using less energy than the blanket 500 lux approach. The latest version of EN 12464-1, Lighting of the Workplaces, was published in August 2021. It considers new knowledge about ambient lighting, requirements for lighting in ceilings and on walls, as well as cylindrical lighting is also important in terms of design requirements. While it's a step in the right direction, however, the standard specifies minimum requirements. We believe in providing a better lit environment for its users, not just meeting the minimum regulations that the regulation demands. Lighting products that use less energy are important, and I don't think anybody could argue with that. But there is a need to balance the performance with the initial outlay of installing solutions which have high energy levels in their production or within the supply chain. It seems likely that this cradle-to-cradle approach to costs will be the main guiding factor for future specifications decisions. And we will speak more about this later in the circular economy element of the webinar. I'll now pass you over to my colleague Stuart, who will look at the recent changes in lighting practices, especially post-pandemic, and how they're affecting lighting design. Thank you, Stuart.
Thanks, Len, and thank you for the introduction. So how can lighting play a part in the switch to hybrid working, and what impact does it have on lighting design? We've all readjusted to post-pandemic working life, with a combination of office, remote, or hybrid working being the new normal. Companies are, in response, accelerating their transition to adopt or refine sustainable, flexible, hybrid work models that benefit both the employer and the employee. This is also being driven by four main forces that are helping redefine the way we work. Technological advances with communication software such as Microsoft Teams and Google Meet are just two examples of the many options available. There's also a strong need for people to achieve a better work-life balance, accelerated by the global pandemic. There's a need for companies to attract and retain talent and become more sustainable, achieving their own environmental, social, and governance targets set at a corporate level. And finally, there's governmental incentives for digital transformation. So, as companies think how best to reappoint their office space, or indeed move to a more suitable premises, we're seeing that workspaces are becoming more flexible, catering for greater social interaction, collaboration and innovation, but with a more informal and relaxed ambience, a bit like a second home or a home from home. An increased number of flexible hot desks to accommodate the ebb and flow of occupants throughout the working week as more workers work remotely or in a hybrid fashion. Facilities in the office for one-on-one meetings or video calls with remote colleagues. I've seen little meeting pods popping up in offices. Accommodating larger collaborative spaces and presentation spaces. A greater need for the adoption of breakout spaces to allow occupants the chance to step away from their computer and a place for mindfulness or drinks after work. The integration of smart lighting controls and building controls include IoT-enabled devices for real-time monitoring and reporting, and an increased awareness of the health and mental well-being of occupants and employees, again, focused primarily post-pandemic. As such, an intelligent and considered approach to lighting of hybrid workspaces will be essential for attracting and retaining the best talent. We must also acknowledge that the hybrid office lighting design requirement is very different, as Len's already mentioned, to that of the open plan, regular recessed panel solutions for working plane uniformity that we've seen in Cat A spaces for so long. So what will this mean for hybrid office lighting? With sustainability at its core, is based around environmental, social, and economic values or pillars. These can filter through to the core elements when considering lighting design too. Design professionals need to respond to the change of an office space. Flexible working gives a greater number of employees the opportunity to hot desk, and we expect to see a deconstructed lighting response to the challenges of hybrid working. We would advocate a layered approach to lighting design with a combination of different lighting styles. The period of transition also presents a perfect opportunity to introduce more energy efficient lighting, even to spaces where already early generations of LED technologies are being used. Len has already mentioned controls, and whilst the concept of control is not new within lighting, modern systems are becoming easier to install and implement. Traditional wired solutions are no longer the only option. Wireless mesh network systems allow communication and control between fittings without the need to change all existing wiring, keeping operational disruption to a minimum. With higher numbers of flexible workers, the introduction or upgrade to smart controls will ensure that the occupied spaces are illuminated as and when required, keeping power densities aligned to occupancy densities. App-based controls also allow both the initial commissioning or end user operation and override to be intuitive and simple. Scenes can be set to create ambience or engaged to allow routine tasks to be undertaken in the most efficient way. Len's also touched on daylight link controls, monitoring of ambient light levels and only supplementing natural light as and when required reduces overall electrical loads, maximizing saving potentials. These points embody the environmental and economic pillars of sustainability, helping companies improve their own energy and carbon reduction targets. With a known space layout, a layered approach to lighting design can be undertaken. Lower level ambient lighting can be used for transitory spaces, supplemented with task lighting related to the individual desk or working area. This helps people focus on their own work, undisturbed by their surroundings or adjacent colleagues whose requirement might be for a higher or lower light level. It also creates a level of visual interest, as low light areas frame pockets of task lighting, delineating spaces visually without having to use additional partitioning. Spaces can further be defined through creative choice, such as the fitting aesthetic, the finish colour of luminaires to denote areas or zones, or through correlated colour temperature, actually using the colour of light to delineate spaces. If, however, the project is still at a Cat A stage, and we can't always get away from this, it doesn't allow lighting design to maximise all the potential benefits we've discussed. In this scenario, the best approach is to design using a fitting with modularity at its core that will allow future adjustments to optics, gear trays, and layout configurations with minimal impact both in costs and luminaire replacement. So we've all experienced poor lighting design. However, inadequate lighting can have negative well-being consequences, extending past just eye strain and headaches. More studies are linking the negative side effects of poor lighting with issues such as depression, anxiety, seasonal affect disorder, as well as reducing the quality of occupant sleep and contributing towards obesity. We expect to see an increase in the adoption of lighting for employee well-being. Tunable white fittings allow for colour temperature and intensity of light to be adjusted throughout the day to support natural circadian rhythms of the occupants within the space. Supporting natural rhythms will help improve sleep cycles and will help employees' overall health and immune systems. In turn, a healthier workforce helps reduce sickness and absenteeism and improve overall productivity. I've already touched on task lighting and how it can help lower power densities and energy and carbon. However, when linked to smart control systems or via local sensors and switches, we have the opportunity to make the lighting user configurable for added control and local visual comfort. The control of the colour temperature, direction, and volume of light can all be easily altered from one user to the next to accommodate individual preference. Seeing should be effortless and intuitive, and we all have personal acuity preferences that no specification can truly cover. These human considerations allowing individual control and support natural circadian rhythms cover off the last pillar of sustainability and lighting design for well-being in the hybrid workspace. I'll now pass you back to John to look at who's leading the way with carbon reduction and sustainability and a case study we've recently installed. John, over to you.
Hello again. Whilst my aim now is to present an exemplar case study of low carbon construction at work and to see what lessons we can learn and apply from this, before I do, I thought it might be interesting to review what some of the companies many of us will have variously worked with, or with whom at least we may be familiar, are doing in this arena. By taking a look at some of the leaders in this field of carbon reduction and sustainability, it may be that we can derive ideas and indeed take some inspiration. Some organisations are well ahead of the curve in terms of carbon reduction. Sainsbury's Stores Limited are entering the next step of a huge multi-phase programme to upgrade their entire estate, including the replacement of fluorescent technology with LED. Fire Lighting have been supply partners on this incredible journey, requiring immense financial commitment for several years, and means that Sainsbury's Group are on a fast track to carbon neutrality. They're probably the leading UK retail brand in this regard. Indeed, their earliest engagement with LED tech was around 2013-2014, and due to the rapid increase in LED efficacy, we are now engaged in the refurbishment of these luminaires, which are otherwise in good condition. An early example of the upcycle phase Stu will talk about later. Landsec are one of the foremost real estate companies in the UK, committed to playing their part in tackling the climate crisis. They have set and achieved testing carbon targets, invested in renewable energy, and significantly reduced energy usage in their buildings. In 2019, In 2019, they became the first real estate investment trust to increase the ambition level of their science-based carbon reduction target, aligning to the much publicised 1.5 degrees Celsius scenario. This year, they successfully reduced their carbon emissions by 42%, in line with the updated target. A leading contractor, Langer, they are embracing digital engineering, modular design and manufacture and delivery of fully integrated building services systems. In their own quest for carbon neutrality, they are designing and delivering products and systems which are both carbon efficient in manufacture and energy efficient in use. Working on multiple projects for the government, they are addressing reductions of embodied carbon as they develop schools that are less carbon intensive. Lighting is obviously a significant factor here, and the aim is always to use more efficient products and fewer of them. Helical Bar have embraced the United Nations 17 Sustainable Development Goals, or simply SDGs, which articulate the key challenges facing the globe. Helical Bar have worked to align their key priorities with the UN's SDGs where relevant to their business and industry. In this process, they mapped their key priorities, which led to their own specific related objectives. These became their 7 principal goals to address to offer the greatest opportunity and/or risk to their business. Resolution Property are developers who have embraced sustainability, and our applied case study, we now take a look at their building, The Old Gramophone Works. The Old Gramophone Works is a new commercial development steeped in musical heritage and situated in the heart of West London's creative district. At around 64,000 square feet of office accommodation and 4 outdoor terraces spanning 6,300 square feet, it was originally, difficult tech. It was originally a building in which classical music records were pressed on recycled vinyl, what presses, to bring them affordably to the masses. Adjacent to the Grand Union Canal in Kensal Rise, and in the Art Deco style, the building originally opened in the early 1920s and went on to house Saga Records, who acquired Trojan Records in 1975, making the Old Gramophone Works the epicentre of reggae music in London, with a backbeat of Jimmy Cliff and Bob Marley and the Wailers. The unique reimagined workspace by Studio RHE Architecture takes its lead from the new ways of hybrid work and with a concentration on space for individuals, rest, relaxation and recreation. Terraces and canal-side cafe bars utilise the vibe and spirit of adjacent West London and the creative forces which abound there. Easy ride canal paths and extensive shower, change and cycle storage encourage a sustainable mode of transport. And whilst not specific to this presentation, fosters well-being, which is a strong theme within the design and construction of OGW elements. The unique architectural design incorporating an express timber structure required a lighting solution that was highly efficient, but also had a visually lightweight and complementary appearance. Design consultants Atelier 10 felt that a new super performance product by Fire Lighting called Momentum was the answer. Beautiful intersecting laminated beam ceiling structure created pockets within which the lighting solution was to be located. Although these pockets were largely constant in size and spacing, they created a challenge to us in that the obvious solution would have led to uniformity issues in dark areas, especially on post-occupancy subdivision. It's a curio, but we sense in some quarters there is still anticipation that the lit LED sections will be in traditional fluorescent lighting modules of 600, 1200 and 1500 millimeters. However, this would require the luminaire to be over or underrun, commonly to the detriment of the solution, its longevity and efficacy. LED, of course, offers greater flexibility than this. So, as the architecture at OGW changed, so too did the lighting modules. The final optimized solution for the open plan areas incorporated an illuminated double length of 840 millimeters, direct-indirect, at each end of a bespoke 2.9 meter length of suspended momentum extrusion. It also utilized twin-channel Dali drivers and meant that the entire 2.9 meter section would be controlled by one driver, saving on capital, installation and commissioning costs. The complexity brought about by a fully exposed all services strategy naturally brought about significant coordination challenges, but working closely with the excellent design and project management team at Dowds Group, the installation engineers, we were able to ensure a smooth progress and on-time completion. According to climate predictions, London is expected to experience hotter, drier summers and warmer, wetter winters over the next 3 decades, with more frequent extreme events alongside other global threats such as sea levels rising. Summer temperatures are predicted to resemble those of Barcelona by 2050, with temperatures in the city as much as 10 degrees Celsius higher than in the surrounding countryside due to the urban heat island effect. Resilient London, by New London Architecture, aims to raise awareness about the urgency to take action in tackling the impact of climate change and reviews the status of climate resilience strategies and action plans across the capital. The ability and skills of the built environment sector, needs for building and designing for a changing climate, and the barriers we face to implement effective resilience approaches in the capital. New London Architecture judges described OGW as a new landmark commercial scheme comprising refurbished, extended and new build contemporary office spaces with green areas at ground and roof levels. By inheriting and adopting existing structural elements, the construction avoids waste, reduces construction traffic and activity, which significantly reduces its embodied carbon footprint. Naturally, we at FI are very proud to have played our part in OGW being chosen as the Environmental Prize winner at the New London Awards in 2021. By incorporating structural timber, LED lighting and controls and using low carbon construction techniques together with a sustainable approach to design, construction and operation, the project was described as an exemplar of low carbon development. The lighting system incorporated at OGW is FI's linear extruded momentum, which has a strong story to tell in terms of efficiency, modularity, and sustainability. This advanced solution is highly adaptable to project requirements, which significantly exceeding current performance guidance. Even so, space usage can change, for example, in the short term due to Cat B fit out, and in the long term due to occupier business evolution, both of which can cause the lighting to fall out of step with requirements. In these situations, refurbishment stasis can be caused by the high capital expenditure of complete replacement, time and disruption, but by designing a modular system, we aim to provide future flexibility, allowing the lighting to quickly, easily and less expensively evolve as the space changes. The outer housing remains consistent and enduring, allowing for modular gear trays, carrier optics, blank infill sections and integrated sensors to be configured to suit the project requirement or later replaced to enable adoption of future technology. Striving to use the most efficient LED light sources will maximise the lumen efficacy of the fitting, reducing overall fitting wattage and lighting power density, thus reducing energy bills and carbon footprints. A clear optical carrier system allows a wide array of technical optical materials to be incorporated or later swapped to meet specification requirements. These include opal, microprismatic, CDP or pocket optic solutions. As an extruded and die-cast aluminium system, end-of-life recycling ensures minimal material waste reaches the landfill. So, to see how momentum fits into the wider picture, and I'll pass you back to Stuart, who will look at the circular economy and TM66 in more detail with you. Stuart.
Thanks, John. So, growing social responsibility and global awareness is driving us to develop more sophisticated analysis and models for the impact of products, as well as a more detailed and accurate picture of what needs to be changed. Steps have already been taken in this direction, but it's an ongoing process that requires constant reassessment. At the same time, the rapid improvement of LED technologies means that serviceable luminaires are being disposed of when in fact they could be refurbished with new light sources or other components to prevent the housings and other components being wasted. TM66 is the result of an industry-wide collaboration and a desire to enable businesses to develop a circular, sustainable approach to lighting and wider engineering services. A full understanding of the scheme's sustainability must also include product life cycle analysis, including all energy and resource inputs and how to minimize the impact on the environment, a cradle-to-cradle approach. Maximizing resource efficiency designs out waste and pollution, keeps products and materials in use, addresses resource scarcity, and also helps to regenerate natural systems. Within our industry, the typical current practice follows a linear economy model. We extract resources from the earth in a take phase. We use those resources to manufacture fittings in a make phase. And at the end of life or change in space use, the fittings are disposed and they're wasted with only some low value recycling of materials. Various WE schemes are in operation to collect waste. However, this material is typically sorted and shredded and not recycled into other light fittings. So this approach has two key problems. It assumes we have an infinite resource to extract from the earth, and it also assumes that we can discard waste and that the earth has an infinite regenerative power. In purely economic terms, however, this is the cheapest way to manufacture lighting for buildings. A circular economy requires changes to be made. This diagram shows a simplified industry approach to the circular economy. It includes phases of make, maintain, upcycle for reuse, and finally, recycling. Here, fittings can go back to the manufacturer either to be refurbished or upgraded or remanufactured into more light fittings at the end of service life. This butterfly diagram by the Ellen MacArthur Foundation captures the wider principles of a circular economy comprising both biological cycles and technical cycles side by side. The left side of the diagram, the biological cycle, is shown here for completeness. However, from a lighting perspective, we need to focus on the technological cycle shown on the right and in blue, which sets out 4 key areas. These key areas make up the multi-point strategy to deliver our philosophy for our clients: manufacture, maintain, upcycle, recycle. So let's have a look at these in a little more detail. To fully implement PM66, it starts at the design and manufacturing phase. You will start to see an increased number of fittings designed for repeated assembly and disassembly, ensuring future upgrade compatibility, which will impact the size and aesthetics of fitting design. Fittings will be manufactured with a higher percentage of recycled materials, reducing the use of virgin materials and single-use components. With time, there will be an industry shift to source materials and components locally to reduce the embodied carbon within fittings wherever possible. And finally, there'll be a recovery or reuse and redistribution phase of previously recovered materials or components to be repurposed into new fittings. During the service life of fittings, the focus moves to maintenance. LED fittings require minimal maintenance compared to traditional lamp technologies, excluding emergency battery replacements. Assuming the first components to fail will be the capacitors within a driver, it gives a mean time between failure of circa 50,000 hours and a fitting service life between 5 to 10 years, depending on operating hours. Benefits of fewer engineer visits and workplace disruptions are clear to see. Unexpected failures do occur, and fittings engineered for easy assembly and disassembly reduce the time required to perform maintenance tasks. The use of quality branded components offers assurance, extending service life, but at an increased cost. It also ensures component availability or succession to ensure maintenance can be undertaken at a later date. Benefits from extended warranties are possible to cover the performance of products supplied in their reuse phase. And at the end of service life, or when the space has changed its use, LED fittings, can be refurbished or upcycled. Rather than disposing of fittings, reverse logistic networks will be called for the recovery back of fittings back to the manufacturer or operational centre to undertake the refurbishment. Fittings will undergo repair and refurbishment, upgrade for reuse, or complete fittings or redistribution of components for reuse. The final stage will, of course, see fittings disassembled for component recovery before key materials are sorted and shredded. The circular economy is about keeping fittings at their highest value for their longest time possible. A quality fitting that continues to deliver the right performance over the long term would normally be favoured over a lower quality one that fails. However, a durable LED fitting could have a life of many years, and there is every possibility that the space in which the fittings are installed could change, as could technology or lighting standards. In such cases, a modular fitting, as John's already touched upon, it will benefit from the ability to be updated and keep up with future specification requirements. Now that concludes my look at the final section of the presentation, and I'll pass you back to John to sum up.
So, in summary, we have seen some of the imperatives to action, both internal and external, legislative and social. Looked at some of the barriers to action and heard about some places where help can be found, including here at Firelighting. We hope you may have found an idea or two, or perhaps been prompted towards a new area for research, as we were in the construction of this presentation. We concluded by looking at the fundamental changes to technology and recyclability and the essential shifts in constructor mindset and approach that this will require as we enter a new phase of luminaire specification and manufacturing. Thank you for taking the time to be with us today, and now Stu will manage the responses to any questions that may have arrived during the presentation.